to its internal power. The TE will retract
Now you'll see that at T-0 via that telltale green spark right before the rocket takes off. That's that T-tub, that igniter fluid. Now regarding the status of the propellant load itself, fuel is nearly fully loaded on stage 1 and is full on stage 2. Liquid oxygen is about 80% or so on stage 1 and about 60% or so on stage 2. But once all the tanks are full, both stages will continue to be topped off with propellant until about T-2 minutes. And we do that to keep the temperatures as cold as possible. The lower the temperature we can bring it to means it's a denser fluid, which allows us to fit more propellant into the same size tanks of that rocket. Now, while those two were propellants, we also have pressurant on board. We need something that will push the propellant through the rocket engines before they light. That is very similar to a fuel injector on a car. Now, we use pressure instead of injection to push that fuel and LOX in, and the pressurant that we use for that is helium gas. Now, helium began loading into the onboard tanks before the webcast went live, but just like the fuel and just like the oxidizer, this loading and top-off process will continue with the helium until about 1.5 minutes before launch. The last milestone that's prop related that we like to hit before liftoff is the engine chill procedure. And that's pretty simple. It's basically just where we open up the valves between the tanks and the engines, and this allows us to flow a little bit of cold liquid oxygen to the turbo pumps so that they begin to drop in the temperature before that full flow of the super chill propellant begins at liftoff.
All right, and today we are launching S-HAIL 2 for our customer S-HAILsat. Now, with the success of S-HAIL 1, which entered service in December of 2013, demand for satellite services in the Middle East and the North Africa region has continued to grow. S-HAIL 2 answers the demand for global connectivity by further boosting broadband delivery and broadcasting in Qatar and the entire region. Now, for those on the ground, that translates to secure communications for the business and government sectors, as well as reliable, high-quality, direct-to-home television content and more. And in order to advance space technology development in Qatar, S-HAILsat has initiated development of new technology for the Qatar Amateur Radio Society. As part of that initiative, S-HAIL 2 will enable the Radio Amateur Satellite Corporation's first ever geostationary communication capability. That's going to connect users across the globe in real time, and it's expected to usher in a new exciting era for radio amateurs in the 21st century. Let's take a look at a video from S-HAILsat about their satellite.
In 2010, the Qatar satellite company, S-HAILsat, was established to manage and develop a sustainable national satellite industry, entering into a strategic partnership with Eutelsat to operate a high-capacity satellite for Qatar's broadcasting, telecommunication and internet services. And Space Systems Loral was selected to build the first high-performance satellite, S-HAIL 1. It would take 3 years to build and weigh approximately 6 tons, eventually orbiting 36,000 kilometers above the Earth's surface. Space Systems Loral provided S-HAILsat with an intensive 2-year satellite engineering internship program for 4 engineers to become the country's first satellite engineers. In 2012, Ariane Space was selected to launch S-HAIL 1 from the French Guiana spaceport. And S-HAIL 1 entered into service on Qatar National Day 2013, with S-HAILsat's 24/7 management center in Doha monitoring TV channels, business and data services. In 2014, SALSat selected the Mitsubishi Electric Company to build its second satellite. And in 2015, a state-of-the-art teleport facility began construction in Doha, which is now nearing completion and set to open by the end of 2018. Meanwhile, the Mitsubishi Electric Company completed work on SAL-2 and shipped it to SpaceX Cape Canaveral, Florida. Now, SAL-2 is ready for launch, and the journey of SALSat will continue. SALSat, space to deliver your vision.
All right, now that was a great video from SALSat, and we're very excited to fly that exact payload from the video just 4 minutes from liftoff here. Now, Falcon 9 is moving into the final stages of the countdown as we speak. Today's launch window is 113 minutes long, about 2 hours, and if for some reason we can't launch today, a backup is available tomorrow, Friday, November 16th at 3:48 p.m. Eastern Time, about 24 hours from right now. Looping back to the earlier status updates, the first and second stages are basically fully loaded with fuel and with oxygen, totaling over 1 million pounds of fluid at this point. They are in their top-up procedures. Remember, that will continue till around T-minus 2 minutes, and that's just to keep everything as cold as possible. Regarding the internal systems, avionics, communications, guidance and control, those are healthy, and we are currently tracking no issues with the Falcon 9 rockets. The second thing we like to check on is the payload. SAL-2 itself has transitioned from external to internal power onboard its own batteries, and they are currently tracking no issues as well. The third and fourth, the weather and the range, we always like to check on these because they are crucial to the successful launch. Weather balloons are released about every 10 minutes, and we saw some thick clouds and some cumulus clouds, but those have cleared and weather is go for launch. And that fourth item, the range, an ever important purpose. They have cleared the surrounding ground, water, and airspace, and they are go for launch as well. Now at this T-minus 60-second mark, as we come in a few minutes, it's a pretty interesting thing that happens. Listen in for the announcement that the Falcon 9 is in startup. Now that implies the vehicle state machine has transitioned to the place where all of the onboard flight computers have fully taken over the vehicle. There are no more humans in the loop at that point. So the onboard autonomy, the software that I enjoy working on, is in complete control of the vehicle. So that's a neat transition from the humans in the loop to the machines in the loop for the 60 seconds before launch. So as we near that T-minus 0 mark, let's listen into the terminal countdown nets.
The activity motions are complete.
Cradle arms open for strong back retract.
Pogo bleed verification. Stage 1 locks close up.
Strong back is at a retract angle of 88.3 degrees.
Stage 2 locks low complete. And Falcon 9 is on internal power.
Ground gas closeout starting. Background gas closeouts complete.
Falcon 9's in startup. Stage 2 press per flight.
Go for launch.
Stage 1 coming up to startup pressures.
It's 15 seconds.
Falcon 9's configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Power and telemetry
Now
nominal.
we've had successful liftoff of the Falcon 9 vehicle as it carries SHALE-2, communication satellite to geostationary transfer orbit. Now we've cleared the towers and we are ascending. The next major milestone as we come up is max Q, that maximum aerodynamic pressure that the vehicle will experience as it goes through the thicker parts of the atmosphere. As we get higher, the density of the atmosphere decreases and there's less and less load on the vehicle. You should hear the call out for that soon.
Vehicle has passed through maximum aerodynamic pressure.
And we've had max Q, so again, decreasing pressure on the vehicle as we continue to ascend through the thinner parts of the upper atmosphere. Now we're coming up on a sequence here where a few events will happen in very short succession. Those events are MECO, stage separation, and then SES-1. Those stand for MECO, main engine cutoff, stage separation, and then SES, which is second engine start number 1, the first of the 2 planned burns today. And those are, MECO is when we shut off the 9 Merlin engines of the first stage, and then once we've shut those down, we separate the 2 stages, and then once the stages are separated, the second stage engine, the Merlin vacuum engine, is exposed to space and it will begin burning. That will happen over the span of about 10 seconds, starting about 20 seconds or so from now. Again, main engine cutoff, stage separation, second engine start.
MECO have stage separation.
Stage separation confirmed.
And back ignition.
And we have had second engine start as the orange glow appears to brighten up the Merlin vacuum engine in the center of your screen. Again, transitioning the responsibilities from the first stage to the second stage. We'll follow both of those vehicles in parallel as we continue this webcast, but for now, the next major milestone is on the second stage, and that is when we deploy the fairings that encapsulate the payload. So SHALE-2 is protected from the aerodynamics of ascent by that fairing. Once we're out in space, the air is not thick, we do not need it anymore, so we drop it to reduce our total mass. That fairing deployment will occur about 10 seconds from now.
Fairing separation confirmed.
And with the fairing deployment that you saw on your screen, we now have SHALE-2 exposed to that beautiful vacuum of space. Now, second stage is going to go quiet here for a few minutes. Remember, you can see the orange on your screen. MVAC is still burning, and this is the first of the 2 planned burns for second stage. This burn will be multi-minute, and we'll return to it in a bit. We'll shift our focuses back to the left of your screen now, where the secondary mission, the landing of that first stage, is targeting the drone ship, Of Course I Still Love You, in the Atlantic Ocean. Now, just like second stage, that first stage is going to conduct 2 burns in its lifetime, and those 2 burns, we've already seen the first one, or I'm sorry, we are about to see the first one in re-entry, and then we will see the landing burn. Now, that re-entry burn is self-described. It's right before we re-enter the atmosphere. We want to slow down our velocity as much as possible. We're traveling very, very quickly. You can see on your screen, we're going 2,300 meters per second or so. It's an extremely fast velocity. We want to reduce that before we actually re-enter the thickness of the atmosphere again. So that's what the re-entry burn is doing, and that will occur about a minute and a half or so from now.
Stage 2 is following a nominal trajectory.
Now, if you're just tuning in, we've had successful ascents of the 2 stages. They have separated. Second stage is continuing on with S-HALESAT 2. First stage is coming back. We're about a minute away from that re-entry burn to slow us down. That re-entry burn itself will last for about 20 seconds, reducing our velocity before we get into the density of the upper atmosphere. A few seconds away now. It's interesting to note, as you can see on the left side, we are actually engines facing the incoming air. So we're going engine first, and that's why the burn does slow us down. As the vehicle burns its engines, that will push us back up. And because we're going engine first, that will slow us down and decelerate the vehicle. Those quick puffs you're seeing are cold gas thrusters that are there to make minor attitude or position corrections on the vehicle.
Stage 1 entry startup.
And that footage is being sent down from onboard cameras in space. So you can see through the choppiness there that the entry burn has started. Remember, 20-second burn in total for the re-entry.
Stage 1 entry burn shutdown.
And the entry burn has concluded. As you can see the exhaust there on the left side. Now we're going to go into the second of the 2 planned burns, the landing burn soon. But it's worth noting that we'll have a very short sequence here as well. While the landing burn is occurring, second stage is going to conclude its first of 2 burns. So you'll see the landing burn start on the left side of your screen, and then you'll see the second stage stop firing on the right side of your screen. And then about 20 seconds after, you'll see the left stage hopefully come down with 0 velocity on the surface of the drone ship. Landing burn start. SECO number 1, landing burn conclusion. And we're about 30 seconds out again. Landing burn, SECO 1, and then landing conclusion. That feed is intermittent. If it does come back, it will show up and pip on screen.
Stage 2 FTS is saved.
Landing bird startup.
And there was SECO. You caught it at the very end there. Don't know exactly what's happening with the landing, but we'll report back for that as soon as we have information. But you saw that blip there at the end where SECO 1, second engine cutoff number 1, did occur, where the second stage stopped firing. We're going to check some data and tune in on first stage here in a second.
Nominal orbital insertion.
All right, landing shut down.
Falcon signal tape.
On the drone ship.
And there it is. The first stage has landed on the drone ship Of Course I Still Love You in the Atlantic Ocean for another recovery and a potential 3rd refurbished flight of this same booster. So with good success of that secondary mission, we'll transition back to the primary mission here, which is the delivery of SHALE-2 to geostationary transfer orbit. And what we're going to do here is what we call a coast phase. It's going to last for about 15 minutes. Second stage has burned its first of 2, and now it's going to coast for a bit before it's aligned properly to execute its second burn. We're going to coast for about 15 minutes now. We'll turn to you with the deployment of the SHALE-2 satellite when we return.
Signal Bermuda as expected. Acquisition signal, Gabon.
Welcome back to SpaceX's launch of the SHALE-2 satellite. Now, if you're just joining us, we've had a successful mission so far. The second stage is in a low Earth orbit, and we're just moments away from secondary engine start to take the SHALE-2 satellite up to its final geostationary transfer orbit. That's coming up in about 40 seconds. So let's watch for SES-2.
Second engine start.
And we've had second engine start number 2 as that Merlin vacuum engine relights, which is not an easy feat to do out in space, to relight a vacuum engine like that. Now this burn will last for a little bit under a minute in total. So we're going to burn through about T plus 27 minutes and a half or so, at which point we'll reach SECO 2, or second engine cutoff number 2.
And then cut off.
And second stage has concluded its second and final burn for that second stage as it delivers SHALE-2 to geostationary transfer orbit. Now what's going to happen here is we're going to coast for another 4 or 5 minutes or so, just like we coasted between first and second. We're going to coast between now and the actual deployment of the payload in its correct trajectory. So we're in a good orbit for now. Stage 2 and SHALE-2 are still mated. We're going to coast for about 4 minutes here, and then we'll deploy the satellite.
Acquisition of signal, South Africa.
Welcome back to our webcast. Now, if you're just joining us, it's a great day for the second stage. We just finished SES-2 and are moments away from deploying the SHALE-2 satellite into its geostationary transfer orbit.
And the deployment of this payload is really the culmination of today's entire primary mission. We have different payloads that Falcon 9 as a launch vehicle flies, and we have different ways to adapt those to the payload. For SHALE-SAT, we need a mechanical connection to hold SHALE-SAT before we push it away. Now that joint is held together with small springs that when we release them, just gently push that payload away into its final orbit.
Now, after the second stage deploys SHALE-2 into its geostationary transfer orbit, that's it for the Falcon 9's mission. However, the satellite's onboard propulsion system will slowly raise its orbit into its final circular geostationary orbit.
So here we go at the very end, the payload deployment coming up about 20 seconds from now.
Spacecraft separation confirmed.
And there it is, a beautiful sight as SHALE-2 floats away again
Also
to provide
signal Gabon, as
communications
expected.
from geostationary orbits. Today was a wonderful day. We'd like to extend a great thanks to our customer, SHALE-SAT, for entrusting us with today's mission. And surprisingly, SpaceX's first mission ever to be attempted in the entire month of November for the entire history of the company.
Really exciting.
So great day for us, great day for SHALE-SAT. We'd also like to extend our thanks to the manufacturer of today's satellite, the Mitsubishi Electric Company, as well as the 45th Space Wing for their range safety, and as always, the FAA for their licensing of today's launch.
Now, we also want to thank all of you, our viewers, for joining us. If you're excited by today's launch and want to join our mission to make life multiplanetary, please visit spacex.com/careers for a list of our current job postings. Please also follow us on our social media accounts for the latest on our upcoming missions and milestones. And with that, we're going to be signing off from Hawthorne and wish you all a wonderful rest of the day.
Acquisition of signal, Mauritius.